Good morning, students. Your teacher here, Mr. Sarasinski, with another episode of Algebra 1. This is a redo video because some of the information in my last video did not work, and I'm not sure why. But so I covered the first 10 examples, including the beginning here in the last set. So in the last video, so I'm going to go ahead and skip ahead to number 11 and start here. So 3x squared. All right, so let's go ahead and get started. Now, in this vertex form, number 11, there is nothing in parentheses with the x. And so that means that the x value for my vertex is 0. And had there been parentheses, outside the parentheses, it would have been minus 7. There isn't, so it's just minus 7. Okay. So whenever there's a value outside the parentheses or by itself, like in this case, it's whatever it says. If it's addition, it's going to shift it up. If it's subtraction, it's going to shift it down. And then we need to go ahead and complete the rest of our table. So 2 values to the left of 0 are -1, -2. 2 values to the right are 1 and 2. So at 1, we are at -4, and at 2, we're at 5. And since this is a quadratic equation, the y values reflect over the vertex. Okay. All right. So let's go ahead and put these points on the graph. -2, 5. Left 2, up 5. 1, 2, 3, right there. -1, 4. Left 1, up 4. Oh, I'm sorry. -1, -4. Left 1, down 1, 2, 3, 4. And then 0, -7. Just down 7. 1, 2, 3, 4. Right here. And then my points are going to reflect. Okay. All right. So connect the dots. Okay, so now we're comparing this graph to our previous parent function. And the transformations that happened, well, I can tell that this graph is much longer and much skinnier than the parent function because this was stretched by a factor of 3. Okay, and this was also shifted down. Shifted down 7 units. All right, that's it for that one. Okay, shifted down and stretched. Number 12. All right, so in number 12, my vertex is at 3, -2. Remember, because the formula has subtraction, whatever you take out for x is going to be the opposite sign. And then the y is going to be whatever is outside the parentheses. All right, so then my values to the left are going to be 2 and 1, and to the right are 4 and 5. And I can go ahead and finish filling out my table. 1 is at -4. I'm getting these values from the table in my calculator. 2 is at -2.5. And these are just going to reflect over the vertex. So this is going to be -2.5, and this is going to be -4. All right. So let's go ahead and put these on the graph. 3, -2, that's right 3 down 2. 2, -2.5, that's right 2 down 1, 2.5. 1, -4, that's right 1 down 4. Okay, and these are going to reflect over the vertex. And connect the dots. All right, so just looking at the graph, there's several changes happening here. The first thing I noticed is that it's a little wider than my previous graph. This is a compression. So we're going to say that the graph was compressed by a factor of 1/2. okay? It was also reflected over the x-axis because this graph is not opening up anymore. It's opening down. So we're going to say reflected over the x-axis. Okay. The vertex was shifted to the right, 1, 2, 3. Shifted right 3 units. And then the graph was shifted down 1, 2 units. Shifted down 2 units. Okay. So now let's put it all together. Given a quadratic equation in vertex form, y equals a times x minus h squared plus k. H is the horizontal shift plus shifts left minus shifts right. It's the opposite signs because the formula has subtraction. K is the vertical shift plus shifts up minus shifts down. If A is negative, the function is reflected across the x-axis. If A, the absolute value of A, is greater than 1, represents a vertical stretch. And if A is between 0 and 1, it represents a vertical compression. Okay. All right, so knowing all this information now, we don't need to see the graph. All we need to do is have the equation, but we can write the equation based on transformations, and that's what we're going to do in these last few examples. It says transformations from the parent function y equal x squared are described below. Write an equation to represent the function. All right, so the first one, number 13, translated 2 units right. That's going to be y equals x plus, x minus 2 squared. So if it's subtraction, it shifts it right. I'm just referring to this up here, okay? Translated 5 units up. That'll be y equals x squared plus 5. Translated 3 units left and 4 units down. That'll be y equals parentheses x plus 3 squared minus 4. Number 16, translated 7 units right and 4 units up. That's y equals x minus 7 squared plus 4. Number 17, reflected over the x-axis, then translated 3 units down. Y equals negative x squared minus 3. Okay, that negative is what determines if it's reflected. Reflected over the x-axis, then translated 5 units right and 2 units down. That's 3 transformations. It's going to be negative x minus 5 squared minus 2. Take your time on these in your homework. You know, think about it. Refer to your table up here. Okay, this is where you can get all the information you need. Vertically compressed by a factor of 1/3, then translated 8 units up. So y equals 1/3 x squared plus 8. And then the last one here, y equals vertically stretched by a factor of 2, reflected over the x-axis, then translated 4 units left. So we're going to have negative 2, right? It has to be a negative if it's reflected. Parentheses, x plus 4, because we're shifting left, squared. I hope this was helpful. Sorry about the problems with the previous video. Have a great day. I'm your teacher. This is the way.